Have you ever just looked up at the night sky and wondered, how did all of this even begin? Well, today, we're going to do just that. We're going on a journey to map the entire universe, right from its explosive birth all the way down to our own little backyard in the cosmos. All right, let's get into it.
So, here's our plan for today. Think of it as our cosmic roadmap. We're going to start at the very beginning with the two main theories on how the universe got started. Then we'll zoom in a bit to those huge cities of stars we call galaxies, find our own solar system in one of them, and then we'll pull all the way back to really appreciate just how mind-bogglingly huge it all is.
And here it is, the whole journey laid out in a single mind map. We are going to follow this exact structure, step by step, to build up our understanding of everything from the ground up.
Okay, so let's tackle the biggest question there is. How did everything, well, begin? Science really has two major ideas about this, two competing theories. Let's break them both down.
First up, we have the one you've probably heard of, the one that's by far the most widely accepted explanation today, and that is, of course, the Big Bang Theory. This is pretty much the foundation of all modern cosmology. So, the story goes like this. It was first proposed by a scientist named Georges Lemaitre way back in 1927. He suggested that about 13.8 billion years ago, everything, our whole universe, was squished into this incredibly hot, dense, tiny little point. And then, bam, it exploded outwards in this unbelievable expansion of concentrated matter and energy. Over billions of years, all that stuff started to cool down and clump together because of gravity, eventually forming the very first stars, the first galaxies, and literally everything we see in the sky today.
But for a while there, the Big Bang wasn't the only game in town. There was another really interesting idea called the steady-state theory, and it painted a completely different picture of our universe.
This one was pushed by scientists named Hoyle, Bondi, and Gould. Now, they agreed that the universe is expanding, they could see that, but they propose that as it expands, new matter is constantly being created out of nothing in the empty spaces. So what does that mean? It means that on the grand scale of things, the universe has always looked the same, and it always will. A universe with no beginning and no end.
So you've got these two profoundly different ways of looking at everything. On one hand, the Big Bang Theory gives us a universe that's dynamic, one that had a definite starting point, a single massive explosion. On the other hand, the steady-state theory imagines a universe that's eternal, always expanding, sure, but also constantly refilling itself so it looks the same. Understanding this difference is absolutely key.
Okay, so the Big Bang created all the raw materials, but how did that stuff organize itself? Let's zoom in from the whole universe to one of its most incredible structures, the galaxy. So what exactly is a galaxy?
To put it simply, a galaxy is a gigantic system of stars, gas, dust, and this mysterious stuff we call dark matter. It's all bound together by gravity. Just try to picture a sprawling, massive city, but a city made entirely of stars.
And the force that acts like the master architect of this cosmic city? It's gravity. It's the invisible glue that pulls billions, sometimes trillions, of stars and all that gas and dust into these huge, beautiful spinning structures. For example, our own home address in the cosmos is the Milky Way galaxy. And if you wanted to visit our closest major neighbor, you'd head over to the Andromeda galaxy, which, fun fact, is actually speeding towards us right now for a mind-blowing cosmic collision. But don't worry, that's not for another few billion years.
All right, time to zoom in again. We've gone from the universe to the galaxy. Now let's find our own specific street, our own little corner of the cosmos, our solar system.
Now, our solar system isn't nearly as old as the universe itself. Its story began much more recently, only about 4.8 billion years ago. It's kind of a latecomer to the cosmic party.
So how did it all happen? Well, it all kicked off with this enormous swirling cloud of gas and dust, basically the leftovers from older stars that had died. Gravity started pulling this cloud together, causing it to collapse and flatten out into a spinning disk. We call that disk a solar nebula. And right there in the center, it got hotter and hotter and denser until, boom, it ignited and became our sun.
And all the leftover stuff in that spinning disk, that's what formed the 8 planets. Circling our sun, you've got the 4 small rocky planets on the inside. That's Mercury, Venus, Earth, and Mars. And then you have the 4 massive giants on the outside, Jupiter, Saturn, Uranus, and Neptune.
So, we've talked about the universe, the galaxy, and our solar system. Let's take a final step back and put all these pieces together, just to truly get a handle on our place in this cosmic pyramid.
I want you to think about it like this. Our solar system, with the sun and all the planets, is like a single house. That house is located in a gigantic city, our Milky Way galaxy. And that city is just one of hundreds of billions of other cities that make up the entire known universe. Yeah, the scale is just almost impossible to really wrap your head around.
So we've drawn a map of what we know, right? But it's a map that has huge, vast, uncharted territories. Realizing that we are just one solar system in one galaxy among billions and billions of others, it leaves you with this really profound and exciting thought. What else is out there, just waiting to be discovered?